Well, good morning slash afternoon slash evening, everybody. It took me a little bit longer than I thought to actually get the stream firing live there, but we are now live. Gregorius, how are you doing today, my friend?
Oh, pretty good. How was your day?
Well, rushing from one thing to another so far. This is like I have my hat, I have my fingers in a few different pies. So I have like three different meetings I have to run in the next 24 hours. This being the first one. Then I've got a meeting 9 o'clock tonight that I got to run. And then I've got the North Houston.net meetup group, which I run tomorrow. So I've been like frantically firing off emails and agendas and getting things organized for all that. So that's been a bit of a circus this morning, but I think I'm basically pretty well prepared for all of them now. So we can basically move ahead with talking a bit about what we've actually been doing on the Akka.net project so far. So let me go ahead and
Mhm.
pull this up here. And we've got a bunch of releases that we've done over the past couple of months. In fact, let me go ahead and toggle this around here. There we go. I liked it better this way before. All right, we'll stick with this. We've done a ton of releases since our last stand-up. So let's dive into some of these. Um, let's see. Akka.net 1.547. Now, correct me if I'm wrong on this one, Gregorius, but this was largely test kit fixes, right? All this stuff. Let me pull this up.
Most of them, yes.
Yeah. So let's see. This fix accept. So yeah, user reported this issue and we submitted a patch for it. And it basically came down to like us doing a whole bunch of just like nested basically a bunch of nested awaits that we shouldn't be doing, and that caused a bunch of mangling around the exception path there. So that got fixed. We fixed some issues with basically. So here's a problem that we ran into. We've got some customers that are running fairly decent size Akka.net like test suites, and they were running into a fairly large number of parallel like timeout scenarios where the test kit wasn't starting on time. So we took one pass at fixing this in Akka.net 1.547, and then we took another pass that I think largely did the trick. And I think this was, let's take a look at this. I think this was largely, yeah, your stuff. Let's see, where's the original? Um, Yeah, let's take a look at this here. I think this was largely your work that you did here, or maybe this was mine. I don't remember, but doesn't matter. Actually, yeah, you designed this class here where we try to run 20,000 instances of starting up the test kit all in a row.
Yeah,
And no, sorry, that's the timeout.
it's
Sorry, we
for
only do
yeah,
40 concurrent test
40.
instances. And we're trying to basically make sure that the test kit does not time out when it starts. Long story short, this is one of those cases where it'd be really useful to have async constructors, although I'm not sure they're ever going to add that to the to the C# language specification. It has been discussed, but the problem here is that in order for us to ensure a clean startup where basically we have access to all the logging details and everything, we need to make sure that I think is it the default test actor? We basically need to make sure that actor is up and running before the
Hmm.
test starts. Yeah.
Yeah.
And that happened. That only takes, I don't know. We're talking like probably less than a microsecond for that to happen. But we do need to guarantee that it happens because the normal synchronous thread of execution for running the test suite can actually go faster than that can in a lot of cases. And we need to make sure that test actor is ready. Otherwise, you end up with these sort of racy test scenarios where the test actor actually isn't assigned yet. That's part of the issue that we had in. We basically do all that work and the constructor. We essentially force the constructor to wait by doing sync over async in order to make sure that actor's ready. Therefore, you can't have those unit tests, sort of failures at startup. Well, if you're running a bunch of Akka.net tests in parallel, all that sync over async can result in timeouts, usually on a CI/CD environment like GitHub Actions or Azure DevOps. We took a couple of passes at fixing this, and while I don't think we've completely eliminated it, we have largely eliminated it. We were running into this problem like the Phobos test suite, for instance. So I think we've largely dealt with a lot of that now. So Gregorius and I took care of that. Next, we have yet another Akka.net release just from maybe a week ago. Akka.net 1.549, which included a whole bunch of random fixes inside of here. This one was strange, and man, this was a trip back in time. I saw that nlog and a log4net and a whole bunch of other old logging libraries all had to solve this problem. Long story short, and Gregorius, you did the original detective work on this. If you're running Akka.net inside of IIS, the normal console.out and console.error get redirected to a null stream writer, which means that if we attempt to log anything using the standard console writer, under some scenarios, this can basically result in a null reference exception that crashes the default logging system, which is not good, shall we say. So I think we fixed this to basically just swap it out. Trying to remember exactly how we fixed it. Let's see.
Well, the workaround is to make sure that everything got redirected to null.
Yeah, I think we basically check right here if the console's available, and if it's not, we just don't log to the console in that case, because it's just console.out just won't work, right? So there's no point in doing it. So that was how we fixed that. That was a weird one. Trip down memory lane. That's a sort of bug I would have expected someone to report back in like 2015, not 2025, but whatever. We fixed it. Fixed that one. This was a this was a real nasty issue where there was a bit of a race, well, not a race condition, but essentially a replicator error in distributed data, where we were not properly handling unsubscribes, and as a result, you could eventually get periodically in a long-running data system, you could get these. What was the exact error being thrown here? Let me pull this up. Key not found exception. There we go. When we're trying to send out notifications via DData. So got that all fixed. That was a little bit of a weird bug that would show up in long-running DData systems. That's been taken care of. Got that done. Let's see. This concurrent async. What was the deal with this Akka streams bug that you fixed here?
Well, inside some of our stages, we use null to signal that something went wrong, or something is shutting down or something like that. But the problem is, well, we're passing it back as an async callback. The problem is that we changed the code on the concurrent async callback to not allow null, and that get prone as an exception. Now, the funny thing is that the original issue was caused by the exception constructor itself. We're trying to create a string that references the object and get the type, but the object itself is null. So an NRE got kicked out.
Good times.
Yeah.
Well, this brings me back to one of the initiatives you're working on for Akka.net 1.6, which we are actively developing now. We flipped the development branch over to 1.6. I think we did that before our August community stand-up. One of the things that we're working on is actively implementing nullability all throughout the Akka.net code base now to try to make errors like this a lot easier to catch a lot earlier, which is a pretty big deal. Now, if we scroll down here, I wanted to actually go ahead and give a little demo of this today. This is the new health check system that we've introduced into Akka.Hosting. 1.548.1 was the first release of it, but now it's in 1.549, which is the current stable release. So I wanted to go ahead and demo this real quickly, which I think I only kind of briefly mentioned it in passing because it was still a beta feature last month. Now it's a stable release feature and you can go use it. So this is the Akka.Hosting, just regular good old code base. And I am pretty sure that it is this sample here that has the health checks enabled in it. Let me double check that. Actors, health checks. Is it
Simple
the simple
demo,
demo?
okay.
Let me double check. It's got to be one of the ones with ASP.NET in it, since we're using the health Z endpoint. Let's see, worker service. That's not it.
Should be the ASP one.
You know what? Let me double check, see if I've got the latest source code available. Let me just go over to my command line here. Nope, I'm not working off of the most recent version. Well, that would explain that.
Want to switch to dev.
Yeah, that's what I'm doing. All right. There we go. this is looking, looks like for a reason my basically GPU acceleration on my webcam wasn't working correctly there for a second. All right, here we go. So I've got got everything loaded correctly now, so this should work properly. This is our Akka.Hosting ASP logging demo. Now, what I wanted to show is the new health check system. We have extension methods like this for actor system liveness check and with Akka cluster readiness check, for instance. These are just simple little one-liners that will, under the covers down here, if we take a look, we'll create an Akka health check registration. And this Akka health check registration includes an actual health check definition right here, Akka health check. And what we're going to do is, in this case, we will return that we are on healthy if the actor system is terminated. Otherwise, we return that we are healthy. So this is a liveness check that basically guarantees that the underlying actor system is functioning. If the actor system is not functioning, we kill it. We go ahead and try to kill the process, signal to Kubernetes or Azure App Service or Windows services or whoever's listening to the health check, really, that not everything is well inside the system here. Now, here's what's really cool. These health checks are automatically getting registered into the Microsoft.extensions.healthcheck sort of the band inside the whole Microsoft.extensions.hosting ecosystem. It's happening automatically without you having to do anything other than add health checks up here. This basically injects the health check builder into the system. And then we are going to, through the Akka.Hosting APIs, progressively add additional health checks to it down here. If you scroll down here, we basically go and add some health check registrations. And then this is where we get integrated into the actual Microsoft Extensions health check service. Basically, we take a look at the health check service options. We call post configure on it, and we just add all the health checks that the user has registered after the fact to that service. And this does, in fact, work. If we take a look at let me go back to the application here. If we take a look down here, we have to call map health checks. That's just sort of a standard minimal web API thing you need to do to go ahead and specify where the health check should be written to. So we call that. And I've done a little bit of extra formatting here just to make it a little bit easier to read the output. So let me run this real quickly. All right, so this shouldn't take too long. All right. Okay, and if I look at the run tab here, looks like everything is up and running. That's all hunky-dory. I can go and pull up in my browser. This is the local sample. I'm just going to go ahead and just bang on this a little bit. Then if I go to Health Z, you can see all the different health checks. So I did that custom code I wrote in that predicate is designed to give me this nice looking, pretty printed JSON here. But you can see the names of the health checks that have been encoded. Akka.actor system, healthy, duration, and I can see the tags that are on here as well. Akka.cluster.join, and it'll record down here. We observed a successful cluster join after 21 seconds. Actual join duration was probably faster, but this is how quickly the health check observed it. That is also very likely true. And you can see the little tags that we've added to it right here. This is a readiness check. This is a little bit different than a liveness check. The idea is that in order for this application to be able to begin receiving traffic from a load balancer, if you have like a web API in front of Akka.net, you might need to be fully integrated into your cluster first in order to do this. That's what this health check is for. So you could do things like, if I scroll down here, let me stop this real quick. You could do things like set the predicate to say, okay, predicates, and let's see, I think is it tags? I'm going to have to remember how to do this. I did do this in one of my samples, but you can set a little predicate to indicate I only want to include health checks with a readiness label. I only really want to include health checks with a liveness label, and that'll all get included this way. So that's what the health check system is all about. It is very trivial to define a new custom health check if you want to. If I go down here, I think the sample's off. We'll go ahead and do with health check. And I could do a new Akka.net health check down here. I might go ahead and say custom actor alive if I wanted to. And then I could just pass in a little delegate where I pass in the actor registry, the actor system, and then a cancellation token. Let me grab that. And what I'll do down here is say, do I have any actors that get registered inside here? Yes, I guess the Echo actor. Okay, let's do that. Or Echo actor. And I can make this async if I want to. Let me do that. Call get async on this. Clean that up. Do an await. And then I could also say, echo dot. Actually, I guess it does just kind of ping back, doesn't it? So I could do this. I could do await like that. I'll do a little try catch block just in case an exception gets thrown, like a timeout or whatever. Oops, go ahead and cut this and paste it up here. Catch, don't really care what the exception is. And in this case, we'll go ahead and return a unhealthy. And I can include a message if I want, or I go ahead and return healthy. And there you go. That is how easy it is to define a custom health check with the new APIs. This was a much bigger pain in the butt with the existing Akka health checks library. So you should expect like a full blog post and some documentation from us on this in the not too distant future here. But that is something I just wanted to kind of bring up as an example. And in fact, let's run this real fast and see if this actually shows up in the output. Okay, let's take a look at the run output. Looks like everything is all working down there. And let me hit reload, and voila, you can go ahead and see that we are healthy and that this took 1 microsecond to go ahead and process. I think that's 1 microsecond. Maybe it's, I don't know, maybe it's 100 milliseconds, whatever. The point stands. Very easy to go ahead and define health checks now. That's one of the big things that we shipped as part of Akka.Hosting 1.548.1 and 1.549. We demoed this, I think, in our August community stand-up. It wasn't released yet, but it's available now. We have now shipped the Akka Discovery.DNS plugin. It's working great, and it's stable and ready for public use. Go ahead and definitely recommend trying that. We've also made the ECS discovery mechanism public and extensible. This was, I think, a user who did this. Yeah, here we go. Which would basically, I think, what were they trying to do here? Discover neighboring nodes or containers running in the same ECS cluster. Gotcha. Yeah. Okay. So this is basically a customization point needed for a lot of people who are running Elastic container services. I haven't been involved in doing AWS for quite some time, so I'm not totally current on all that stuff, but that's available now as well. And then the next things that we kind of wanted to dive in on is talk a bit about what's new in Phobos. We'll get to that in our show and tell. Last couple of things I want to touch on is what's going on with our future updates for Akka.net. So the Akka.net 1.550 milestone, so far the biggest thing we fixed is that, let me see if I can actually grab it real quick. That error that you added support for, Gregorius, for missing SSL, or basically invalid SSL certificates was a big one. So let's see. I think that is on the milestone here. Let's grab it. One closed. Yeah, here we go. Long story short, .NETty is currently responsible for handling things like certificate validation when we get a new, when we basically are trying to do encrypted communication over Akka.remote. Apparently, the way it dealt with handshake failures where someone provided a bad private key to a certificate was some mechanism we never thought to look at, namely a user-defined event. I don't know, would have made more sense just to shut the transport down, but that's me. But anyway, we weren't handling that properly before. We ended up wasting a ton of our customer ended up wasting a lot of time tracking this issue down. So we patched it. This will come out in the next release of Akka.net. We've also backported all these changes to Akka.net 1.6 as well. And now I want to talk a little bit about Akka.net 1.6. The big stuff we've been working on with 1.6 so far is we've been adding nullability to some of the base class libraries. That's been Gregorius's backlog project, in addition to fixing racy unit tests. That's been a big one. The other thing that we've been spending some time working on is starting to remove stuff we don't want from the public API surface anymore. I am just wrapping up a big project now, this Phobos dashboard and this stuff that we're going to cover in the next segment here. So I literally am wrapping up that project today. I'm almost done with it. I just got to publish a blog post. The next big thing I'm going to be working on is a whole bunch of internal plumbing on SDK bin. That's probably going to take me 2 or 3 weeks to wrap up. Once that's done, it is all Akka.net 1.6 between here and the end of the year. The big thing I really, really want to get out the door soon is a beta that features full AOT support for the core Akka.net module. Now, one thing I'm wrestling with a little bit is whether we can get Akka.Hosting under AOT. I kind of suspect not, due to the way some of these the dependency injection primitives work in that library. But you know what? We won't find out until we try. So that's something that we will take a look at, and we'll see what can happen. Hopefully it will all work. But that's kind of that's sort of the name of the game so far. And now, with all of that being said, I think we'll pivot on to our show and tell and talk about primarily, we want to talk about Phobos 2.10, but the real big thing we want to focus on is the new dashboards we introduced as part of it. I guess before I shift onto this, Gregorius, is there anything else on Akka.net 1.6 I forgot to mention?
No, I think that's pretty much it. Yeah.
I don't think so. Gregorius, you still there?
Yeah. Can you hear me?
I think your mic's having trouble again, man. All right. Well, on that note,
now?
I will go ahead and start with our show and tell. So one of the other big things I did over the past several weeks is we completely redone the Phobos website. Now, I had a few motivations for doing this. First and foremost is obviously to sell more copies of Phobos, our product. This helps directly fund the development of Akka.net, which is super useful. But the other reason why I wanted to do it is this is a DocFX website. This is all using the exact same templating mechanism that we use for doing Akka.net's official documentation. I wanted to see how well we could customize it and how well we can make it look. I'm really happy with the results here. This is a pretty slick looking landing page built using DocFX, which if you've ever worked with it before, DocFX is enormously clunky. Now, if I go to the documentation and we take a look at our release notes. So we released Phobos 2.10 maybe a couple weeks ago. We've done a couple really important things with this release and with Phobos 2.9 before that. First, we have brought back the most popular metric we had from before we ever supported OpenTelemetry. That metric is called the mailbox depth metric. It basically allows you to measure how many unprocessed messages are sitting in an actor's mailbox at any given time. It's a very effective way of measuring back pressure and backlog inside your system. And not only have we added, so the reason why, by the way, it took us so long to add this back is because, in my opinion, the OpenTelemetry people did something really heinously stupid with the original standard for several years, which is they never bothered implementing a plain vanilla gauge type. The only gauge type they had was called an observable gauge, which basically runs on a timer in the background. And that's useful for some values that can be observed independently. But if you have a million actors running inside a process and you want to measure the mailbox depth of each of them independently, well, having a million observable gauges means your process will probably be using more CPU power running those observable gauges than it will actually doing work. So really glad they added a regular good old-fashioned gauge again. That allowed us to restore this metric back to its former glory. So that's there. Now, let's actually go and take a look at it real quick. This is the brand new Phobos dashboards. We have two of them. We have our Akka cluster dashboard, and then we have our performance analysis dashboard, which allows us to take a really deep look at individual actors and understand how well they're performing. If you've seen any of our Phobos videos before, this dashboard probably looks pretty familiar, but there's several important changes you should be aware of. The first is we no longer use any of our own private labels in the dashboard for being able to do filtering on the instance of your application. Instead, we use the OpenTelemetry standards now. We use the OpenTelemetry job, which is the combination of the service namespace and the service name that's here. And we also will let you filter by individual instances of the service if you want to down here as well. That's one big change. The other big change is something we did in Phobos 2.91. We've made it really easy to filter the actor metrics based off whether they are user-defined workloads or system-defined workloads. The reason why this is important, in a lot of cases, the metrics that come from system-defined actors, such as the Akka.Cluster sharding system, are significantly higher traffic than the user-defined workloads are. And that can kind of crowd out a whole bunch of the metrics that you might be interested in for understanding how your code is performing in production. So you can just filter that out by selecting the user type down here. Other things we've added is this summary table. This is basically a set of spark lines that kind of show how each of the nodes that are available up here are performing in your cluster. So you can see which roles they have, what version of your software they're running, what their status is inside the cluster, and you can also see the fluctuation in things like the total number of actors, messages per second, logs per second, and the error rates on here as well. This application is relatively busy. We have about 3,000 actors on each node, and we're processing about 500 messages per second on average inside of here. So those are some of the new things. Our logging sort of selection here is pretty much the same. That's not really changed all that much. But we have changed quite a bit some of our actor metrics that are on here. The first big change is that we now break out the message processing volumes by whether they are a system or a user-defined actor. So you basically are able to kind of keep track of like where is resource consumption being driven in your system. So you can see here, for instance, our user-defined messages per second is about 500. Our system messages per second is about 4,500, so about 10 times as much, which makes sense. A lot of that is going to be the sharding system and Akka.remote and other pieces of infrastructure inside the system here. Next, we have the actor mailbox backlog. This is going to tell you how much your system is slowing down when you're processing messages inside of here. Now, backlog of 0 is great. That means that as soon as a message gets sent, it gets processed almost immediately. I'm not surprised that our backlog is this low because these actors running in our test lab are spread out and are basically running in Kubernetes instances that are running on bare metal. There's no virtual machine layer or anything like that. It's not a public cloud environment where we have noisy neighbors. And our number of like containers per server is pretty low. We probably have, I don't know, at least for here, probably at least 5 servers that are all running it, and they're pretty beefy. We're relatively high-end computers, more or less. So I'm not surprised the backlog is that low. And then if you take a look down here, you can kind of see the breakout of all the live actors that are spread out across each of these processes. You can see a breakout of the total actor throughput by type down here. And then you'll notice when we're looking at the live actors by type and the actor message totals, these are all restricted to the actual message types that we are distributing inside our user space. Now, a question from Pavel here. I know that Phobos is a licensed product. Is it possible to check it without pay in a trial mode? Go ahead and contact us. Let me pull up the Phobos website real quick. This is a good question. Go ahead and click the contact us link here and if you want to go ahead and request a trial, we will do it as long as you're, representing a real company and we basically have your email address and everything. Go ahead and contact us there. I also mentioned on the Twitter thread about this that, we'll go ahead and do trials and evals on a limited basis. So it won't be forever, but we will let you go ahead and try it for maybe 30 days. So go ahead and give us a shout, and we will try to accommodate you with that. All right. But yes, good question. Okay. Now, where was I? Next down here. The other things that you can see on this dashboard, you've probably seen this before in some of our videos, but if you haven't, this is still useful. You can see the distribution of where shards are inside the system and where sharded entity actors are inside the system as well. That is very useful for being able to kind of understand like where entities are spread out throughout your system. All of these different little objects down here, these are all the different shard regions we have. We have a bunch of them in this particular application. I don't know, 7 or 8 different shard regions. And I can basically look at where they're distributed roughly evenly inside this application here. So that is the cluster dashboard. The cluster dashboard didn't change that much, but it still has a lot of improvements on it. The dashboard that changed quite a bit is our actor performance analysis dashboard. This used to be known as our latency dashboard. Now, what we've done here is we've redesigned it so it is much more focused around essentially offering a performance profile of a specific actor inside your system. And when I say actor, I don't mean a single instance of it. I mean an actor type is what we're looking at. So these are all the different actors inside our system that we can take a look at. And if I want to filter this down to just my actors that are running in the application, I can select the actor category. And I can see that we only have these, I don't know, 5 actors to work with. But I'm looking at this across all the different workloads inside this application. Let me go ahead and shift down to just this workload right here. Okay. Now I can only see there's 2 different actors at work inside the application so far. So I can see that there's a total of 28,000 of my entity actors alive over the past 30 minutes on average. They've processed a message volume of 405,000 messages and a throughput of about 225 messages per second. And I can see the distribution of all the messages that these actors have processed. And this is like, I think, all time. They have processed 253 million over whatever the retention period is of our Prometheus server, which I think is 14 days. I can take a look at their latencies down here, and their P99 latency is 3.46 milliseconds. Again, we're still running inside Kubernetes, so these are all containerized workloads, but it's pretty much underneath that, it's just bare metal. So the latency values are pretty low on here. If you want to see something shocking, let's go ahead and take a look at this same chart on SDK-Bin's live monitoring system. This is more shocking because SDK-Bin is running on Azure Kubernetes service. And this is a much lower traffic application. I mean, we're probably doing a tiny fraction of this traffic on here. So it's a much lower traffic application. But look at how much higher the latency values are. So this is for the shard actors. This is a system actor here. You can see the distribution of all of its messages. It's probably the busiest actor inside the system. And let me switch to only our production NuGet service, since that's where most of the action's happening. Our P99 latency can spike as high as 10 seconds sometimes. And we have 3 seconds, 4.43 seconds. And this is for a much smaller workload by comparison. And then the latency heat map will tell you roughly how many, basically, it'll essentially break apart the latency processing metrics into different time bands. And you'll see that there's some periods where we have several messages that end up in this 10-second or greater bucket up here. That is shocking to me, considering how low traffic this application is. What it tells me is that the cluster that we're running on in Azure Kubernetes service is basically running on like hardware that is less powerful than most people's mobile phones, is what that tells me. And so we're probably vastly overpaying for the hardware that we're running on there. So that's kind of impressive. The other thing that you might notice on here is, let's see, we have our message processing rates by type and our message backlog. Message backlogs all look pretty low on here, so not too bad. I can also see that we don't have any unhandled messages or any dead letters from this actor, which is good. And if I flip over to some of the other actor types, let's take a look at, I don't know, the command listener here. Nothing there. If I take a look at my package download counters actor, okay, we got some of those alive right now. That's good. And I take a look at its backlog. That's set to 0. Not too bad overall right now in terms of the total volume of traffic in here. So I spent a fair amount of time getting all of this stuff in place and redesigning the dashboards and doing some of these Phobos updates for 2 reasons. One is that we have paying customers that go and ask for improvements. And we are very responsive to that. So we've been fixing some of those issues. But the other reason is that we recently deployed, an Akka.NET cluster to SDK-Bin. We did that probably 3 weeks ago. And I started taking a look at the existing dashboards that I had, and I thought these things we could do a lot better. And that's why we went through and we improved it. We improved the Phobos website. We also really improved the Phobos Quick Start as well. This is our Quick Start sample. So after you buy Phobos, or if you get a trial of it, as Pavel mentioned, if you get a trial of it, you can basically sit down here, fire up the sample, and all you have to do to get it to work is pass in your SDK-Bin NuGet credential into the NuGet.config. And Gregorius wrote this sample to use .NET Aspire over the past couple of weeks. So you can just launch it and it'll run. It'll automatically give you access to a Seek instance where you can look at the tracing data from Phobos, which we haven't even talked about yet. Or you can take a look at the dashboards that are already built in here and kind of get a feel for how it all works locally. In fact, I think I've got this set up down here. If I go and launch this real quickly, we should be able to see it in action. So let me do this. Okie dokie. You can see .NET Aspire is launching. All right, so it's going to launch the OTEL collector. It's going to launch Grafana. It's going to launch Seek. It's going to launch, we use Azure Table Storage here for doing service discovery. So we can run like a 3-node Akka.NET cluster on bare metal. These processes are running just directly using the .NET host. We're not using Docker or anything for them. All right, so everything's up and running now. And I can actually take a look at the traces and metrics in .NET Aspire if I want to. So for instance, if I scroll down to, let's see, I think our cluster should be formed by now. Go ahead and reload this. Let's see. All right, looks like we're up and running. I can see down here a little trace where we have a background service that runs on a timer. I can see that this actor, let's see, where is it? This router forwarder actor received a message of type string, and I can see that it's at what its actor path is down here. And I can take a look at some of the events that have been added to the string, so I can see how long it spent waiting. I can see basically the content of the string and any Akka.NET logs that might have been recorded. They all get automatically appended to the trace down here. And you're eventually going to see this actor crash and restart. That's intentional. We programmed the actors in this demo to do that. You can also see some dead letters and some other things appearing here as well. So this sample is designed to be really useful to help you get up and running quickly. If you want to take a look at like kind of what our production APM stack looks like, this is what we run in our test lab and what we run on SDK bin. We use a combination of Prometheus, Grafana, and Seek. We do not use .NET Aspire for metrics in production. So here we are in Seek, found a dead letter. I can go ahead and show the trace and see where this all came from here. And I can even see, looks like an actor got killed via poison pill and it stopped, and a message that was sent to it ended up in dead letters. All right, that makes sense. Pretty useful. And then if I go into Grafana, I can pull this up. And you can see all the same dashboards you just saw me using earlier already pre-installed here. Now, in this case, they're being loaded using the raw JSON files. The preferred way of installing them is going to Grafana Cloud, and we have links to this everywhere. Going to Grafana Cloud, click copy ID to clipboard, and you can just install this via the Grafana. If I go to dashboards, if you go to import dashboard, you can just paste that ID in from Grafana Cloud, and that'll automatically install this directly into your application. So the one caveat here is that these dashboards are built to work with PromQL. That's the Prometheus query language. That's kind of the lingua franca of all telemetry at this point. We've got customers that use like Azure Monitor under the covers, and that has a PromQL adapter in front of it, or at least a Grafana adapter. And they're able to use these dashboards to actually get that data out of that APM service directly. I'm sure Datadog, Elastic, and a lot of the other APM stacks all have some sort of similar adapter you can use. So we're just focused right now on maintaining one set of really well curated dashboards. We don't want to get back in the business of trying to juggle them for every single platform. There's just no way we can stay on top of that. So that's all I've got as far as our show and tell presentation goes. Now, Gregorius, you mentioned in the private chat that your microphone may not be working. Can you try it again real quick?
Yeah. Can you hear me now? No. It's still dead.
Yeah, it looks like your microphone is still DOA. Sorry about that. Well, no worries. Well, anyway, if you have questions about Phobos, if you're interested in giving it a try, please go ahead and contact us. Let us know who you're working for, what your use case is, and whether you'd be serious about buying it at its price. That's obviously relevant to us. And let us know what we could do to make it even better for you and your team. Otherwise, we'll catch you next month. Hopefully, we'll have some more exciting updates about Akka.NET 1.6. But otherwise, thank you all for your time and attention today, and we will see you next time. Thank you very much.